All set? Oh, there we go.
Yep, you can go ahead and get started, Bill. Thank you.
Okay. Well, thanks for having me here today to talk to everyone, and welcome to all the interns. I'm sure you've been welcomed a bunch of times, but it's still good. Can everybody see my screen?
Yes, we can see a screen.
Okay. Well, I'm Bill Burns. I've been with Red Hat 13 plus years, which is amazing. And I recently, well, about a year ago, started this pushing this Operate First initiative, and I'm going to explain it to you today and how it's kind of fits in with open source in general and Red Hat and what we're trying to do. Without any further ado, I'll get started. Part of this is about how things have changed over quite a bit of time in computing, right? So in the beginning, open source was not really there. Code was the value. Maybe most of you are probably pretty young, so your parents probably could relate to this better, but paying license fees for software and so forth. And open source provided a way that anybody could run software for free, right? And the way that Red Hat made its money doing this was in not charging licensing fees, but charging really for support, what we call entitlements, so that we developed a staff to certainly harden and make enterprise ready open source, and a support staff to help people using it. So anyway, that's where the value really was, and open source tipped the scale and made it fairly level. And the thing that kind of happened at this point, open source was equivalent to proprietary, and things were coming along pretty smoothly. One thing that became evident is that operations became more important. And in this third slide of the pictures here, it shows you that with the cloud consumption model, that's where the operations have become critical, right? So just an aside here, a little story is during my lifetime in working in computing, there've been countless numbers of startups that happened. And to start a company that required computing power, typically required a huge investment to build up a big lab, right? And people don't do that nowadays. They use a public cloud provider for the computing resources. So it takes, there's a much lower barrier for companies to start up. They need less cash, they need less money, less time to build up an environment. They just consume computing from cloud computing providers. And that's really changed the consumption model of computing across the board. And it tends to be the kind of de facto way that things are done. And so operating the software is something that the cloud providers do, and there's real value in that. And open source code is still utilized very heavily. And the piece that's missing is that the operation of that code is not available, or how it's operated is not open. Most cloud providers basically develop their own techniques and tools and don't share that with the community. So that introduces a problem that is something that we consider to be a threat to the viability of open source, of providing an alternative to proprietary. So that's a little bit of history. And then part of this is where Operate First came out of. And it's to answer this question, can open source continue to be an alternative to proprietary? So this slide basically tries to describe that and tells you that when the value is in the IT operations, then open source has a bit of a problem if it can't compete. So operation of code in the cloud environment is something that is needed for open source to remain relevant. So what is Operate First? With Red Hat here, we have upstream first as a basic tenet, is that everything that we do basically is in the open and shared with the community. And sometimes we might acquire a company whose code isn't open, and we work diligently to open that up and make it available. So we do that across the board. So the idea of Operate First is to have a scheme where besides developing code in the open, we want to make sure we develop the operations of that code in the open. So it's a way of doing development. So it includes taking your code and not just releasing it to the world, but taking it to a production cloud and running it in that environment. So the developers actually understand the nuances of running it in a cloud. They work with the cloud operators, and together they can evolve open source operations related to their code. So, and being in the cloud gives the developers the opportunity to vet how their code operates in the cloud, and you know, functionally, does it have issues? Does it have scale issues with as our cloud scales up or whatever? But also just the operational characteristics and how it intersects with other pieces of the cloud. So, and so why? I mean, this is a little bit redundant from what I've already said, but having developers bring their code to a production cloud, it gives them direct access to the cloud, and it helps with the things I've mentioned already, and it gives the developers something that we can't get, or our support team something they can't get in a customer situation. So typically, like if a customer reports a bug with some software being used in the cloud or being used in a standalone case, right? A case is created, and support looks at it and says, oh, okay, well, we need this information. And they have to get log files, or you have to get this data from the customer, and there's a lag time there and so forth. With Operate First, the developer, if the problem occurs in the production cloud that we are providing, they can go themselves and log in and look at the logs and get the data immediately and be solving problems very quickly. So anyway, so that's one of the reasons. Then how? So the way that we're doing this is we've want to give developers access to production clouds and completely open access, so they can do their own triage and own experience and learn about the operational environment, which again, with a proprietary cloud provider, you don't get that. There's a wall there where you have to deal with their operators to find out, but you can't do it yourself. Okay, and it generates a quick turnaround. So what we've done is we have a great partner in Boston University and the Massachusetts Open Cloud, which is a data center that they've built over the years that actually it's out in Western Massachusetts, nowhere near the university, in a hydro-powered data center. So it's a Massachusetts Green Computer Center. And they've been providing cloud computing services to their students and to research and other academic institutions for quite some number of years now. And in our partnership with them, we've sliced off a piece of their hardware and created an Operate First environment at the Massachusetts Open Cloud. And this is where their prior cloud was based on OpenStack. We now have an OpenShift-based cloud on bare metal with OpenShift virtualization, which is kind of the new wave. And they have an experienced operations team, and they are featuring an expanding array of hardware where they're bringing in new servers as well as new computing devices. If you've most of you probably have heard of GPUs. The DPUs is the next generation of more general purpose ancillary processors, and we're bringing some of those into the environment as well. And so this is an environment where you can take your pre-release software that's in development and bring it to this cloud and work with the operators to get it installed and understand how it operates and actually utilize that cloud and develop knowledge from it that you feed back into your development. So, and we've been doing that now with several different projects. So here's an early success story that we had just about maybe a month, 2 months ago. where there was a reinstall being done of the environment, and there's a lot of moving parts to a cloud, and there was a new version of OpenShift and new versions of other pieces of software. So it ran into issues trying to install the new cloud servers. Ran into a problem. The installations failed. And so the debug went on with the ops team, and it was resolved within a day. The very next day, the problem was worked around. And it was an interesting issue because ACM, which is the Advanced Cloud Manager, which is really a high-level piece of software that one would use to manage their cluster, right? Advanced Cluster Manager, I think I said Cloud Manager. If it failed, right? It said the installation couldn't happen. And it took a lot of digging down to figure out that a firewall change in the networking in base OpenShift had changed, which had didn't break ACM directly, but it broke the bare metal installer that was being used. And then there's a piece of open source software called Hive, which ACM uses to talk to the installer. And of course that failed, and then ACM failed. So by the time the error bubbled up to the top, it became, it's not an easy thing to figure out. And so like the last bullet here says, the ACM team noted that if this came to them from a customer, it would have been a real bear to diagnose and fix. They might have had to bring in experts on networking and experts on this, experts on that. And with the kind of lag that you have in getting information from a customer system, it could have taken quite a long time. And because they were working hand in hand with the other folks that are operating first at the Mass Open Cloud, they were able to work with them, understand it, and put workarounds into new versions of software that are coming out that if to better detect this, avoid it, and continue. So it's a great success story, really. It showed the value of bringing together pre-release software in a cloud environment to work out issues and not have those kind of bugs or issues reach customers. So now the benefit and cost of this is really pretty straightforward. The benefit is pretty clear, I think. And then the cost to a project is really involvement in taking someone from the development team that understands what they're developing and bringing it to, and working with the cloud operators, So so that's really the cost, and it's not a commitment of you need to take an engineer off of your team and send them to the Mass Open Cloud to always be there. It's to be available, as something goes wrong or some issue comes up, and it's to spend some time there, to gather the operational knowledge and bring it back to the development team. And this is not just about Red Hat products either. It's about any open source project. Open source projects that feed Red Hat products can operate first the Mass Open Cloud, and as well as a Red Hat engineering team that is taking the open source and making a product out of it can be operating first at the Mass Open Cloud. And the idea here is really the Mass Open Cloud won't be the only place to operate first. It's the idea is that this is the incubation point, and there will be operate first becomes a normal methodology of developing open source software upstream and with products, and that will be done in lots of different places. Excuse me. And the other piece of this, which is my last slide, and I'm happy to take any kind of questions and talk about this, is the Open Infrastructure Labs. So if you've heard of OpenStack, which is a on-premise cloud, right? The organization that built OpenStack is called Open Infrastructure Foundation, and they have created something about a little bit over a year ago called the Open Infrastructure Labs. And that piece of the Open Infrastructure Foundation is about cloud operations. And what has kind of happened is, as people try to run their own on-premise open source cloud, fully based on open source and not using a public cloud provider in the background, they struggle. And they struggle because open source has not had really a focus on operations, on cloud operations. And the public cloud providers who have advanced the state of the art aren't sharing their information back to the community. And so, especially as interns, many of you are coming from, institutions of learning and doing research on computing. In order to do research on the whole gamut of computing with open source code, you need to have the operations piece. So the idea of Open Infra Labs is to provide a place where providers of clouds and their operators can work with developers to enhance the state of the art of open source clouds. So, for example, if the Mass Open Cloud has developed this with us, they've developed this OpenShift on bare metal environment that they can clone and create. And some people have referred to this as a cloud in a box. And so the prescription for that, or the way to do that and the tools to do that, are being put in to the Open Infrastructure Labs upstream repository. Excuse me. And so that's the place where anyone can go if you want to build a cloud based on the pure Kubernetes, or if you want to build a cloud based on any other open source technology. You could bring it to Open Infrastructure Labs and provide the tooling and work with other operators to put together that version of a cloud. So you can have an OpenStack based cloud. It could be Red Hat's OpenStack. It could be any version of Red Hat's OpenStack. It could be the upstream OpenStack. It could be, like I said, Kubernetes, or it could be OpenShift, whatever. So that it's a community. It's intended to be a community where folks can decide how they want to run open source clouds, and it provides the window of opportunity for academia to work and do research on this as well. So that's really a key component. That's where the operate first work being done at the Mass Open Cloud is being open sourced, is up at Open Infra Labs. So operate first is a concept. It's how you do development. You bring your code, maybe early and often, as in a DevOps type environment, to a production cloud, and you learn about the operational characteristics of it, and you embed that into your product, and open source is all the better for it. And then working in this environment with the Open Infrastructure Labs, we're looking to build, a community of operators so that open source remains relevant with in these new days of cloud computing, with as relevant as it was in the past, which was very relevant. So anyway, that's my little presentation. I hope you found it informative. Happy to answer any kind of questions and go from there.
Thank you, Bill. I think there was just a small conversation going on. John just wanted to clarify if you mentioned DPU or TPU as the new general purpose auxiliary processing units.
DPU is the one that the tag name that is given to it by the company whose equipment we're putting into the Mass Open Cloud. So it's DPU. I think it would. Data processing, is that what a deep unit? I think maybe, I don't know. I forget what the acronym stands for, I'll tell you the truth.
It's data processing unit.
Okay.
Yeah, I think other people call it IPU, another company calls the same concept IPU, and there are other names. The point is that I think we are training to call them ICUs, intelligent compute unit. The point is it's it's like a subsystem, like a network card that has its own CPU, so you can offload things to it.
And some of the usages for it in the mass open cloud are the AI space are looking to do work in DPUs as well as the networking team for OpenShift. So they're excited about that. And there are a lot of other interesting things happening around that the mass open cloud with something called ESI, which is Elastic Secure Infrastructure that allows you to move hardware from one cloud to another and interact with some of the other open efforts as the Open Cloud Testbed and several others. There's a whole initiative called the Open Compute Initiative, where Open Cloud Initiative, I should say, which what they're trying to do is really address this whole fundamental thing of of a portion of the computing environment kind of being closed off by proprietary cloud providers. And educational institutions want to run their own clouds. They need to do it for their students, so the students can participate and learn and work on that aspect of computing as well. And so there's a lot of effort coming from different places here that kind of jive together. So.
Awesome. Does anybody else have any questions for Bill?
Well, if anybody comes up with any, bburns@redhat.com, feel free to shoot me an email question. I'll be happy to help. And I hope this helps folks who are coming into Red Hat to understand this. Operate First is not widespread yet at Red Hat. We're working to onboard more and more teams to doing it. And, it can become, it's an interesting thing to do. Everybody seems to like the concept, but the kind of workflows that people have to generate releases and all of that, they have to kind of change that. So it's a bit of a change for the way that a lot of engineering teams work. But we've seen, like I said, good benefits. And if we had everyone coming to us to try and do this today, we would not be able to satisfy the need because the cloud couldn't handle it, so we're building that up and all that. So it's still in the kind of the early days of a slow process of a change. And so you may, as interns, you may run into this in the various groups that you're working with. So, so feel free to reach out any point in time. Happy to talk about it further.
Thank you once again, Bill. And just to also add to that, we do have a hands-on session later this afternoon. So this will be by Tom and Humair, who will do a sort of introduction to how you can onboard yourselves into this Operate First environment that Bill just presented. And you can hopefully get a better idea in terms of if you want to get access to this cluster for some of the projects that you guys are working on. I think that would be quite an interesting session for you guys to attend. So I would highly recommend attending that this afternoon for more information about this Operate First environment. All right. I do not see any more questions, but thanks once again, Bill. And
I had one question.
Yes,
sorry.
go ahead, Surya.
So what was before Operate First? How people used to test their open source code?
Well, that would vary, I guess, based on the open source project or the Red Hat product. We use continuous integration here at Red Hat, and we test in a standalone lab, basically, to some form of scale. And there's a performance lab where performance is evaluated, but our quality testing only goes to a certain point. And when you kind of go over the wall towards cloud computing, where your component is going to interface other components and test everything as a whole unit, typically that actually happens in the cloud. And again, it's what has to be done to the code or to deal with it by proprietary cloud vendors is they don't necessarily share it. Google has shared their SRE techniques, and that's gained a lot of traction, but they don't open source everything that they do. And other cloud providers are less open. And so So today you run into problems, and you run into problems on public clouds when new software is brought there, and it doesn't really work right, and it can be difficult to debug too. So today we try and test stuff at Red Hat and as wide a scale as possible short of this, and this becomes, I think, the next level of integrated testing, if you will, where things are run together. So in fact, one of the dialogues I have going is with our QE department, a quality engineering department, who to look at this as something that they embrace and include. So besides the developers that write the functional code, the team that tests it, work together to bring it to the mass open cloud, or to an operate first cloud, wherever it may be.
Wow, thank you.
You're welcome. All right. Well, thanks. Like I said, thank you very much. And feel free to reach out if any questions come up. And I don't want to knock you off your schedule, so take it away.
Awesome. Thank you once again, Bill.